Okay. The discriminant. Easiest thing you'll do for the rest of the year, easily, is the discriminant. Nothing else will get remotely, oh, and multiplying and adding complex numbers and stuff. This is one thing that did pop up quite a bit on that Unit 4 test where people miss these, and they should. These are really simple. How do we, I think this class was a little better with this stuff. How do we multiply complex numbers? What do we do? Just distribute, sure, we just distribute. We treat the I like a variable, right? Except there's, what's I squared equal to?
-1.
-1, good. So we'll distribute the 10 through, 10 times 2 is 20, 10 times 10i is, good, 100i. We'll distribute the -10i through, -10i times 2. I, good, and then -10i times +10i. Minus 100 I squared. And the I squared is equal to?
-1.
Good, so that's just gonna make this whole thing equal to +100, right?
This guy, he was ahead of the game.
Oh, nice, that's good. Okay, and then all I do here is add like terms, right? So I end up with, these are like terms, right? So I'm gonna get 120, and these are like terms, right? So I'm gonna get, what, 80i? And that's my answer. No big deal. Okay. How about stuff like this? Okay, let's look at complex number in standard form. Okay, so we're going to write this as a complex number in standard form. So this is all that stuff about complex plane, right? Remember what we said about this. The horizontal axis, normally the x-axis, is the real axis. Okay, and the vertical axis, normally the y-axis, is the imaginary axis. And so what are the coordinates of this point in the complex plane? -8, -1, good, okay. When we talk about writing a complex number in standard form, what is standard form for a complex number?
A equal plus 2b? No, b squared?
A plus b times I, right?
I
Okay,
forgot.
so every complex number can be written in this standard form. This is the real part and this is the imaginary part, right? So if the number is real, then the imaginary part is just 0.
Oh, that's the one I got wrong on that test, remember?
Yeah, and this is an easy one. When you retake it, this will be an easy one.
Yep.
So if the real part is -8, and I want to write this in standard form, then that's just going to be -8 plus what? The imaginary part is the part that's going to be
-2.
multiplied by I.
Plus
So it's -1i, and we wouldn't put the 1 there, would we? We would just write this as -8 minus I. Okay, make sense? Okay, no big deal, no big deal. Easy stuff. So go to Unit 5, and let's take a look at,
To be honest, I'm just a little bit confused on that.
okay, on this one?
No, the last one.
Oh, okay, let's go back.
I mean, it's -8 minus 2, but. I mean,
But no, it's not, it's -1, see?
Oh, that's why. Okay, yeah, I'm on the same page
Okay.
now. That's
Yeah.
good.
Oh, there was one that I had that was the absolute value. They gave me like a root.
Okay, right, okay, so when you're looking for the magnitude of this number, right?
Oh,
So all we're looking at then, if you want to find the absolute value of a complex number, right? Really, all that means is just the length of that vector, how far it is from the origin in the complex plane. So you can always just use the formula, the square root of a squared plus b squared, right? We call that the modulus, right? So if I wanted to find the modulus of this complex number z, we would just say the modulus of z is the square root of -8 squared plus -1 squared, right? So that's going to give me the square root of 64 plus 1, square root of 65.
Which one would be like one where there's like a constant?
Oh, you mean like where you could simplify this and get a number outside? Well, that would just be an example, like what if we ended up getting something like, oh boy, what's going to be an example here? Say if we had something like, okay, yeah, like say A was equal to, we had the complex number. Here's an example. So if Z equals 4 minus 6I.
So it would just be simplified.
Yeah, that's all you would do is simplify the radical. Yeah, does that make sense? Okay. Okay, let's look at the discriminant a little bit. The discriminant is really simple. I mean, easiest stuff you'll do in Unit 5 and maybe the rest of the year would be the discriminant stuff. You just have to understand what it means, and maybe that's the problem. Pull up that assignment, how about? And let's just... Okay, so the discriminant. In the quadratic formula, right? Now this leads into the quadratic formula, so it's perfect. The quadratic formula, we make the assumption that if we can write a quadratic equation in standard form, so if we can get it into the form, which we always can, ax squared plus bx plus c equals 0. It's got to be equal to 0, right? Then what does the quadratic formula tell us? X equals negative, okay, keep going. Plus or minus. Right? Okay. So, what does it mean to discriminate? Well, seriously, what does that mean? Think about the definition of the word discriminate. What's it mean?
To leave someone out.
Okay. Okay, how about to separate? Right? To separate into groups, maybe, right? If you have discriminating taste in something, it means that you're able to pick only the very best of whatever it is that you have great taste about, right? And the rest you'll discard, right? There are ugly forms of discrimination in our history, but what it comes down to is separating things, right? So the discriminant is just, it's a number which allows us to separate quadratic equations that have real solutions from quadratic equations that don't have real solutions. Essentially, that's all it is, right? So what's the part of the quadratic formula that's going to determine whether or not we get imaginary solutions instead of real solutions? Good, yeah, it's going to be the part in here, isn't it? Right? Remember talking about this? So the part inside the radical, because if we get a negative number under the radical, that means we're going to get i's in our answer, right? We're going to get imaginary solutions instead of real solutions, right? So that's the part, that's what we call the discriminant, is just b squared minus 4ac, right? So if b squared minus 4ac is greater than 0, if it's positive, what's going to happen? Am I going to get i's? No, I'm going to get real answers. How many? Two. One for the plus and one for the minus, right? So that means I'm getting 2 real solutions. Okay, what if b squared minus 4ac is exactly equal to 0? So the discriminant equals 0. What's the square root of 0? 0. So I can just get rid of that whole thing, and I only get one solution this time. I don't get 2 separate solutions, because negative b plus 0 is exactly equal to negative b minus 0, right? So the top is going to be the same, the bottom never changes, right? So in that case, we just get one real solution. But what about the case where the discriminant is negative? Then what happens? Yeah, then I'm getting non-real, I'm getting imaginary solutions. How many? 2. One for the plus and one for the minus. Right? So let's look at a couple examples then. So what about something like this? These, I would claim, we can do really quickly. You don't even have to do the math a lot of times. You can do this in your head. So b squared minus 4ac, that's going to be 25, right, is b squared, minus 4 times 9, 4 times 1 times 9, so 25 minus 36, positive or negative?
Negative.
Negative. You don't even have to know what the answer is. We know it's negative, and if the discriminant's negative, which one has to go with that?
1.
The one with imaginary parts, right? And it might also say something like 0 real solutions. That would have also been the correct way to do it, right? Okay, make sense? Okay, how about this guy? Okay, now, the answer is, I can tell you right now what the answer is. It's positive discriminant, 2 real solutions. How come?
Because you're multiplying positive with positive.
So, okay, yeah, I think,
9x is positive.
because what?
9x is positive.
Sure, okay, but if I want to do the value of the discriminant, geez. What do I get if I plug in numbers? So I'm going to get 9 squared minus 4 times 6 times negative 2.
2 negatives.
Yeah, exactly, right? Now think about this. We always are going to write, when we write a quadratic equation in standard form, we always make a positive, don't we? Right? Like if we started off with something like this, what if we started off with a quadratic equation, negative 2x squared minus 7x plus 3 equals 0. That's not really in good standard form. What would we do?
Make it
Divide by negative, well, negative 1, or multiply by negative 1, because we want this to be positive, right? So we would just effectively change all the signs. If we multiply both sides by negative 1, we'd get 2x squared plus 7x minus 3 equals 0. Now it's in standard form, right? We want a to be positive, not negative, right?
So if you change all the signs.
So we just change all the signs. Yeah, exactly. Okay? But it's set equal to 0, so it's easy to multiply both sides by negative 1, right? So if that's the case then, why am I saying this? Well, if a is always going to be positive, then all we have to do is just look at the sign of c. If c is negative, well, what happened? We ended up with a negative times a negative makes a positive, and so we get b squared, which is always positive, plus something else that's positive. So the result is, for sure, positive, right? And if it's positive, what happens? If the discriminant is positive, yeah, 2 reals, right? Okay? So that's pretty simple. You don't even have to really do the math. You can just look at that one and say, oh, positive. Because I'm going to end up, minus 4ac is going to end up giving me a positive result, right? Okay. Try another one. We have to probably figure it out, but we can find out, right? 24 squared minus 4 times 9 times 16. That's going to be negative, isn't it? Yeah. Because 24 times 24, if I do 9 times 6 times 4, that's the same thing as saying 2 times 9 times 2 times 16. You see what I'm saying? So that'd be like saying 18 times 32 is definitely bigger than 24 times 24, right? Or is it? I think it's going to be 0.
Would you like to vote?
Yeah, it is. It's 0. It's 0. I'm going to get 576, and yeah, it is, it's 0. Yeah, it's 0. You have to do that one. That would use a calculator. You can't. Okay, what about that one? What do I have to do there first?
Multiply and divide. Oh, wait, no.
That's 3.
Add 3, right? So I gotta put it in standard form. It's gotta be equal to 0, doesn't it? So this one would become 2x squared minus x plus 5 equals 0. Well, pretty obviously, the discriminant is going to be what? Negative. Yeah, we're gonna get 1 squared is only a measly little 1 minus 4 times 2 times 5. I'm definitely getting a negative result, right? So, negative, which means that one, right?
It's not even what it says. Two complex solutions with.
Okay, this one, what would I have to do?
Figure out the right side or the left. Or what's right.
Meaning, okay, good. Which side am I gonna push everything to? Left, good, because I want A to be positive, right?
What if you pushed all the stuff on the left to the right, though? But
Well,
it's
then I'd
still
end up with, okay, I mean, I could do that, but I'm just making more work for myself. Then I'd end up with a negative x squared.
But it still would work.
Well, okay, but then when I'm all done, I'd have to multiply everything by negative 1, right, to flip it, see what I'm saying?
Yeah.
So it's easier just to push everything to the side where the number of x squareds will be positive. So if we subtract, so what do we end up with then? 2x squared minus x squared is x squared, 9x minus x is 8x, 1 plus 15 is 16, so I'm gonna get 0, aren't I? 8 squared minus 4 times 16, 0, okay? Okay, moving on. How about stuff like, what about that one? Yikes.
Oh, this one, I just guessed, so I got it right.
Ah,
Yep.
what do you got?
It's going to be positive.
It's pretty hard to tell just looking at that, isn't
Good
it?
guess, bro.
But how do we deal, there's an important lesson that comes out of doing a problem like this. Okay, what's obviously really ugly about that equation? Fractions, yeah, and I think it's ugly too. I'm a mathematician, but we don't want to be adding up all these fractions if we can avoid it, right?
Yeah.
So what do we do? We talked about this earlier in the year. There's a great little trick we can do if we've got an equation that involves a bunch of fractions.
Flip them upside down.
Can't do that. But we have an equation, right?
Something
So as
about
long as they treat both
denominators.
sides equally, I'm okay.
Times them both by 2.
Times them both by something. 2 won't quite cut it, but what can I multiply both sides by?
4. 16.
16 would work. I don't have to go quite that big though.
8.
8, yeah.
I knew
I
it.
could multiply both sides by the least common multiple, meaning least common denominator of all the denominators, right? This is, and we talked about this earlier, but we don't do this a lot, so I understand why it's not something you immediately think of, but it's a great strategy. Look what happens here. If we distribute that 8, 8's the same as 8 over 1, right? So if I distribute that to the first term, what do I end up getting? I end up getting 8 over 1 times 1 over 4 x squared, right? Okay?
Plus,
So we could multiply straight across, right? And get 8 over 4 is what? 2. But we don't want to do that because we could end up with very large numbers. We have handpicked the number 8 because all of the denominators divide evenly into it, right? So remember the little trick that I showed you guys. Instead of doing multiplying straight across, what you're always going to do is reduce everything. So I need to give myself a little bit of room here.
what do you mean by reduce?
Okay, here's what I mean. When we're clearing fractions, we can say 8 divided by 4 is what? 2 times the numerator is what? 2. See the trick? 8 over 2 is
4.
times the numerator is,
4.
What?
see how that works? Okay. 8 over 4 is
195.
Really?
times the numerator is 6. See how much easier that is? You multiply smaller numbers that way. Okay, over here, 8 over 8 is times negative 1. Negative 1. 8 over 4 is 2 times 1 is 2, right? Now that looks much more manageable, doesn't it? Right? Now we get this down to a point where the fractions are gone, no big deal. Now what do we do?
Add the
Like-
stuff to
Yeah, good. Good. Push everything left, combine like terms. So we'll end up with 3x squared plus 4x plus 4 equals 0, right? And now we could either, if we wanted to solve it, we'd use the quadratic equation. If we wanted to find the discriminant, it's going to be negative, isn't it? 4 squared is 16. 16 minus 4 times 3 times 4 is definitely negative, right? Okay, but the trick there is clearing those fractions. Once you clear the fractions, it makes it way easier, right? Multiply, distribute through both sides by the least common denominator, and always reduce first and then multiply by the numerator, okay? Okay, what about stuff like these? Just by looking at that, how many x-intercepts are there?
0.
0. X-intercepts correspond to the real zeros of a function, right? So if I've got a function that I'm writing in standard form, like this guy, right? If I'm writing it in standard form, the solutions of this equation are where the function equals 0, right? Where y equals 0. So those correspond to x-intercepts. So the connection we're making then, we can simplify what I just said. X-intercepts on a graph always correspond to real solutions of the equation, right? So if we say that then, if there are no x-intercepts, 0 x-intercepts, how many real solutions are there? 0, right? So we know it's going to have 2 complex solutions with imaginary parts and 0 real solutions, right? And what kind of discriminant do we connect with that?
0.
No.
Positive. Negative.
Negative, right? If the discriminant's negative, that's where we get i's. So we'd kind of work backwards on this one, wouldn't we?
That's what I do.
Based on the graph, we can see that we've got 0 real solutions, which means the discriminant that goes with that has to be negative. Even though we don't know what the function is even, right? But we know whatever it is, its discriminant would have to be negative.
It's like cash in the
Okay? So it's like doing a puzzle backwards. All right, so how about,
Easy.
how about something like that then? It's got what?
2.
2 real solutions, so it must have 0 solutions with imaginary parts. Okay.
Great.
And that means the discriminant is positive. Boom. All right? Okay.
I don't understand.
Okay, this one right here,
I don't want to.
the other one I did? Okay, so let's go back. Let's see. Previous. Okay, that one, right? That one, so this one has got, it crosses the x-axis in 2 places. So it has 2 x-intercepts. So that means, 2 x-intercepts means 2 real solutions, right? So we know that this one's got to have 2 reals, which means if it has 2 reals, it's got 0 imaginaries. It can only have 2 at the most, right? And so if it's got 2 real solutions, think back to what that means for a discriminant. That means that
Goes
the
over the
discriminant, right, the part under the radical, has to be positive to get two real solutions, okay? And then the next example we did, we said, okay, this is a different one. Okay, what about this one? How many x-intercepts does that have?
One.
One. Okay, so if it's got one x-intercept, it's got one real solution and 0 imaginary solutions, right? And so what would the discriminant have to be there?
0.
0, good, it's only got one, so it's the 0 one, okay? Yeah, you got this stuff, right?
That's one
All right, so moving on here.
real solution.
Okay, what about, let's look at the next assignment. So,
You got a weird finger, bro.
Good.
You get the strength there.
discriminant we did. Okay, so graphing quadratic functions. So let's just, take a second and do a little review, and then we'll look at the newer stuff. How much time we got?
Enough.
Enough. Yeah, good. Okay, enough time.
13, 4 minutes.
Okay, choose the graph of this quadratic function. All right, so what form is this in?
Standard. No. Yeah.
What form is that in? What do we call that?
Quadratic.
Well, it is quadratic, but what form? What are the forms?
Oh, vertex.
It's vertex form, isn't it? So that's vertex form. What are the other two choices we got? Vertex form or standard form? Or, no, standard and general are the same thing. We really should call it standard. What's the new one, you remember?
Factor.
It's broken into factored form. Yeah, good. So those are the three, that's it. Those are our three choices, right? This one's in vertex form. So this one's in the form f of x equals, what? You tell me, what's vertex?
X minus Y. No, A.
H, good.
Yeah, that's not plus B.
Plus, okay.
What are we missing?
What the heck?
A, yeah, good. We need A, right? The dilation factor. So then we can just look at this function. We can say, okay, what are the values of those parameters? A equals what? I heard it.
2.
It's 1, is it? Because it's the number in front of the parentheses. There's nothing there. So what's that mean? It's 1. Yeah. It's being multiplied. If it's invisible and it's a factor, it's 1. What's H?
7.
Good. 7. What's K?
4.
Okay. So that's easy then, right? That's all the information we need. This thing is dilated, the vertical, the y values are multiplied by 1. So are they even changed? No. No, so it's not stretched or compressed at all. We'd go over 1 and up 1, right? All we need to do though is move the vertex over to positive 7, positive 4. So you guys tell me then, tell me when we get to the right one. Right there. Is that it?
No,
How come that's not it?
because
It's over 1 and up 2, right?
Uh,
So that one's been stretched vertically, so that's tricky. That one's not it.
So that one.
That one's been squashed, right? Because it's going over 2. If I go over 2, I normally should go up 4, right? So that
So it's
one's
half.
been compressed. So
Bingo.
that's it, bingo, right there, right? Over 7, up 4, and it's a normal shaped parabola, over 1 and up 1, right? Okay, good. All right, let's try another one. Whoops. Okay, that's same thing, right? That's in vertex form, everybody
It's
agree?
times 4, so it'll be up 4 over 1.
Good, okay, so if we.
It's gonna be negative, negative.
Let's get it down just a little bit.
Nope.
Okay, good, so we've got A is 4, right? Everybody agree?
Yeah.
Where's the vertex? What are the coordinates HK? -5, +1. Good, okay? So we've got to stretch this thing by 4, and we've got to have the vertex located at -5, 1. So we just got to find that, right? So -5, 1. There's -5, 1. But I go over 1 and up 1. That's normal. I should go over 1 and up how far? 4.
Oh,
Right there, looks like, right?
bingo.
Okay.
No, because it's -5. That's -5, -1.
Oh, you're right. Good eye, Aspen. That's good. Bingo, right there.
Bingo.
There we go. Good. Okay. Man, I was pretty tricky on these, aren't I? I tricked myself.
Yeah, it's hard to guess on those ones. I actually know how to do this. I don't guess.
Okay, so that one's, what about this guy? Look at one more of these.
That one.
No.
Okay, good. So A is what here? So I'm going to multiply all the normal y values by -1/5 this time, right? And h and k are where?
-1.
Okay, so let's try this then.
Oh, I told you it's.
So -3, -4. Well, let's try that first one. What do you think about that?
It's gonna be negative. It's gonna be in the other.
So look at this now. Is this normal? Let's look at what this does. So to go from my vertex over to this point, I'm going to the right by 5. Normally, if I go right by 5, how far up do I go on my y equals x squared?
25.
25, right? So normally I'm going up by 25. But this time, I'm going down by 5. That works, doesn't it? 25 times -1/5 is -5. So it's the right dilation, isn't it? And it's the right vertex, over 3 and down 4. So that's it. Okay? We got it. Okay, what about standard formula? Okay, well this is just the opposite. We could do that, right?
Yeah.
What's A gonna be for this one?
5.
-6, yeah. Because instead of going over 1 and up 1, we're gonna multiply +1 by -6 to get -6, right? So A is -6, what's H?
4, -1.
Well, H is gonna be 4. We're gonna subtract H though, right? H is 4 and K is -2, right? So then what does that mean? What are we gonna get for our answer? We had to write this out. We're gonna get -6 times x minus 4, right? Squared minus 2. Yeah. Okay. So we got that. Okay, what about standard form? There we go. Okay, so we're going to write the vertex of this thing. That's in standard form. How do we go about graphing a function that's in standard form?
You use the graphs with multiplied 24 or something added.
Well, we just, think what we did in the last ones. We just found H and K and A, and that's all we needed, right? So what's A in this one?
4.
So A is 4, right? Coefficient of x squared. So A is 4. Turn it, let's come on, back into the, don't get distracted. So what about H? What's that?
I'd never get distracted.
We gotta use a little formula, right?
Negative
over
EB
2A.
over
Negative B
2A.
over 2A, there you go.
There we go.
You taught me that.
I did,
Why
it's
was
true.
that supposed to be-
So what's negative b? 24
And then times.
over 2 times a is
4.
over 8, so what is that? 3. Okay, so h is 3. How would I find k?
Plug it back in.
Plug it in.
Shoot, I'm not even that bad.
So k is gonna equal f of 3. So if I plug 3 in, what am I gonna get? I'm gonna get 4 times 3 squared, that's 36, minus 24 times 3 is 72,
plus 31.
plus 31.
Then those equally. no, they
So
equal each
I'm gonna get positive 67 minus 72 is negative 5.
Yeah,
Right.
sure.
So,
other. I should do that.
so I get the vertex is gonna be at 3, negative 5, right? And, well, that's it. That's all they wanted for this one. If I were trying to graph it, I could do it now. I would just know that I'm gonna stretch it by 4 and put the vertex there and we're done, right?
I can't remember what town Stanford in.
It's in Palo Alto, but it's actually its own town. But it's technically, people say it's in Palo Alto.
I gotcha. It's, the school is its own town?
Mm-hmm.
Really?
Mhm.
Is that big?
The the undergrad population is, how big do you think the undergrad population is?
25,000.
Nope, 5 to 6,000.
5.
It's pretty small, but it's got about the same number of grad students. But the campus itself is huge, 8,800 acres. So it's a huge campus, but not a very big population. I could be a tour guide,
Yeah. Tell me something else. Come on, give me some facts.
And some facts. This is kind of an interesting fact. If you took
Oh,
If you took the combined economic output of Stanford alumni, it ends up being like the 5th or 6th most powerful economic country in the world. If you look at just the facts for you.
That's awesome.
And
Okay.
best athletes
I'm
in
not
the world.
contributing much to that, though, let me tell you.
Yeah, you are.
I'm bringing the average down a little bit. So what about this? If I want to choose the graph of this function, I don't have much time, just tell me, how would I do it? So what about the 2?
H and K.
A is what? 2. Okay, good. H and K I would get by using,
Negative B over 2A.
yeah, that gives me H, right? And then to
Plug
find
it in.
K, I would just plug that value into the function. That's all I need. If I have the vertex and the dilation factor, I can get the graph, right? Okay,
Simple.
good. All right,
That helped, that's all.
good.
Give her a request.
Good. So how about if we continue, let's take one more day tomorrow to kind of continue going through this stuff. Here's what I'm gonna do. I'm gonna put up the last few assignments from this section, or basically just review. I'm gonna put up an assignment where you're just gonna get some more practice solving quadratic equations, but it's not gonna say solve by completing the square. It's just gonna say solve using the best method. So that's one. The other one is gonna be easier than that. It's gonna be, I'm gonna give you an equation and you're gonna have a multiple choice question that's gonna give you some different choices, and it's gonna say, what is the best method for solving this equation? And you might say, well, I could do it many ways. That's right. But math is partly about choosing the best way to do it. And there is gonna be a correct answer, right? In some cases, it might be isolating x directly. If I could point to a single x, then I would isolate it. That's easier. If I can find magic numbers very easily, what would I do? I'd solve by,
Complete the square.
well, no, if I could find magic numbers, I'd factor, right? If A is 1 and B is even, I could complete the square, right? Otherwise, I just use the quadratic formula.
Would the following students come to the office? Elizabeth House, Kyra Jackson.